Good morning, good evening, wherever you are. My name is Mark Borstein, again, co-author, Kubernetes and Enterprise Guide Second Edition, along with my co-author, Scott Surovich. Last week, we got Docker up and running in our lab. This week, we're going to get KinD up and running. Throughout the rest of the book, we use KinD as our distribution for all of our labs. There were some questions, why did we go with KinD? Ultimately, KinD gave us the best balance between getting something up and running quickly, but still being able to customize. One of the issues with going with something like Minikube is Minikube's great for automated testing, but all of the parameters and the settings are all hidden. It's got its own interface. And so we wanted you to be able to get into the nitty gritty of configuring Kubernetes to still be able to go through a lot of these different labs. And we didn't want you to expect you to have a cluster up and running, from one of your favorite cloud providers. Really for a couple of reasons. One, again, those cloud providers hide a lot of the configuration away from you, and we didn't want to assume that your enterprise clusters were going to be running on any particular cloud. We wanted to give you the ability to configure everything. And so KinD gives us the best balance of those two. The really fun thing about KinD, Kubernetes and Docker, is that not only is it Kubernetes, but it's also kubeadm. It's just running kubeadm, well, not just, but it's running kubeadm under the covers, which a lot of enterprise distributions, on-prem distributions actually do. They're automation on top of kubeadm. And so this gives you a leg up there as well. So what we're going to do today is we are going to take our Ubuntu VM that we created last time with Docker installed, and we're going to get KinD up and running, and then we will play around with high availability KinD. So with that, the first thing we're going to do, I'm on page 37, and let's go ahead and install kube control. Now for this particular deployment, we're going to go with snaps. I'm not generally a huge fan of snaps, to be honest, but it does make the installation much easier. So first thing we're doing is installing kube control. So that's all done. And now I'm on page 38. And the next thing we're going to do is get KinD up and running. So we already have kube control set up. So let's go ahead and get KinD. So we want to make sure we're using the same version. So I'm just copy and pasting right out of the book. And so let's go ahead and verify that we got KinD running. And we do, KinD version. Let's make sure we match up what's going on in the book. So that wraps up page 38. So KinD is now deployed. Now the really cool thing about KinD is you want to get something up and running quickly, just KinD create and you're off to the races, which is what we're going to do right now. And it's going to do everything. It's going to pull down images. It's going to set everything up. The great thing about KinD is that it is all automated. And to be honest, if you have software that you're testing, KinD's a great option because that also got built-in API. I learned that one when we recently updated the kube proxy. I saw that they were leveraging KinD's API for standing up clusters, pushing images into it without having to have a separate registry. So some really great APIs. All right, so our cluster is deployed. We have our node images running. We got our control plane going, and we have a context set up. So we do a quick Docker PS here. We'll see we got a couple of containers running, or we got one container running. We got a control plane up and running, single node cluster. All right, so we are now on page 40. So kube control get nodes. And so we've got our context all built up, and there it is. We got our control plane up and running. So now we have our cluster. Let's go ahead and delete our cluster. That's the other great thing about KIND. You know, you don't need it anymore, then that's it. You're good. You're done. Like you can actually do a KIND list or KIND get clusters. There you go. So let's go ahead and delete our cluster. KIND delete cluster name is KIND. All right, so that'll delete our cluster. So that's a great thing. It's disposable. Fire up a cluster, you do some testing, you do whatever you're going to do, shut the whole thing down. The nice thing is that we're going to go through a bunch of steps in the rest of this chapter, but Scott's put together some great scripts. These are honestly my go-to at this point for whenever I need a quick cluster to do some testing, and I'll point those out at the end of the video. So, like I said before, KIND is built off of kubeadm, which means you can actually put in whatever you are going to configure kubeadm with into KIND. So that gives you a lot of flexibility. So I'm on page 41 where it talks about creating a custom cluster configuration file. And so if we go into, might have gotten some updates there. So let's go ahead and take a look at chapter 2 and cluster 01 KIND. So YAML, because it's Kubernetes. Everything's YAML in Kubernetes. So this is a cluster configuration file. This is the same one inside of the chapter. But again, you can see it's just kubeadm config patches. So you can use this to apply anything. We go ahead and expose a few ports. We expose 80 and 443 for ingress. We do that for a little bit later once we actually start deploying stuff into our clusters. And we're exporting port 2222 for SSH. In the last chapter in building a platform when we deploy GitLab, GitLab has SSH for Git. We can't run SSH on port 22 because we're SSH'd into our server. So that would not work. So we're going to map port 2222 to SSH in a bit. So we're actually going to come back to this configuration file in a bit. The next question is, well, what about multi-node? You know, production, you don't want to run with just a single node. KIND takes care of that for you, which is really cool. So we're going to go ahead and create a simple multi-node cluster, which this configuration is not. So I'm going to go ahead and take the config right out of the book. multinode.yaml. And so what we've got is we have, oops, I didn't copy everything correctly. So what this is going to do is when we go ahead and launch KIND with this configuration file, it's going to go ahead and create 6 containers, 3 control plane containers and 3 worker containers. So again, if we want to test high availability, let's say we want to test our failover, we want to test how an application is going to react, it's all built in right here. We don't have to worry about standing up multiple VMs and getting those things running. So it really does make for a very powerful testing environment. And let's go ahead and run this. So KIND create. Cluster. Let's get the right command here. Oops. Config. Multi-node. Oops. Oh, I once again messed this part up. All right, let's go ahead and run this configuration deployment. So once this is done, we will have multiple nodes and multiple control planes. All right, so we can see that our cluster has deployed, and do a quick Docker PS. We got a bunch of nodes and an HAProxy. The HAProxy is used to load balance across all of our control plane nodes. And so I'll do a kube control get nodes. And there we go. We've got 3 control plane nodes and we've got 3 worker nodes. So we now have a highly available cluster. So if we want to start testing different things, we can. Oops. Control get namespace. And then we'll also see that we have our namespaces and local path provisioner gets deployed automatically by KinD. So if we want to be able to provision something that uses local storage, obviously just for testing, we have a place that will handle that. Okay, so now that we have shown how to deploy a multi-node cluster using KinD, the next thing we're going to do is deploy a new multi-node cluster using KinD. But this time we're going to build it out so that's actually kind of useful. We're going to add Calico, and we'll talk about why we need to add Calico. We're going to add Nginx ingress controller, and then finally we're going to add an HAProxy to act as a load balancer. So earlier in the chapter, Scott talks about kind of the nesting dolls, as he calls it, of Kubernetes networking. So you deploy these ingress controllers, but the ingress controllers are not listening on ports. You need to know where to hit the hosts. So you set up a load balancer in front. So next chapter, we'll talk about Metal LB. But in this one, we're going to just set up a simple HAProxy to get that up and running. So you can see if you want to use KinD and you really want to test HA, how can you do so rather easily? So the first thing we did is I'm on page 56, and we took the configuration from page 56, and we have it right here with HA demo. And so this is a configuration that I'm actually going to add to the repo because copy and pasting can be a little difficult coming out of these books. But a little more complex than our previous configuration for KinD. This one adds, in addition to our multiple roles or our multiple nodes, it also adds pod subnet and service subnet. This is going to be useful once we get to CNI setup with Calico, and I'm actually going to fix this indentation because this is not going to work well. So. The joys of embedding YAML in YAML. All right, so let's go ahead and create this cluster. So KinD, create cluster, name, cluster 01. If I could type, that might help. And then config HA demo. Oops. There we go. So that's going to go ahead and deploy a KinD cluster. And we'll be back in a moment. Welcome back. We now have a running 6-node cluster. We'll run Docker PS. We'll see we've got, again, 3 worker nodes, 3 control plane nodes, and an HAProxy to load balance our control plane. And if we do a kube control get nodes, and there you can see we have our control planes, and everything's showing is not ready. Why is everything not ready? Because we don't have a CNI yet. What's a CNI? That's the Continuous Networking Interface. That is how Kubernetes knows how the network should work between pods. If you're using something really basic, often what you'll use is flannel, that is what's called a overlay network. It's like the most basic networking interface you can get. Um, Here we're going to use Calico. That gives us a little more capabilities, like being able to control the network space, the IP space, etc. Um, and so we can tell that we need our CNI, because if you look in the kube system namespace, and if I knew how to type, kube, there we go. Okay, so you'll see that these core DNS pods aren't running. That's the quickest way to know that you've set up a cluster and nothing is available yet, because if core DNS isn't running, that's because your networking interface doesn't work yet. So the first thing we're going to next do is go ahead and um, set up our Calico. Let me get the instructions in here. So we're kind of jumping backwards a bit in the book. And so we are back to page 49. Now, we didn't want you to have to worry about whether or not files move, so don't worry about it when you see a kube control create F and there's a URL in there. We actually went ahead and just imported everything. So I'm going to go ahead and create our Calico file. Calico. So that's creating, and what's happening here is Calico runs with an operator. We'll talk more about operators later on in the book, but this operator is looking for a Calico custom resource. That custom resource tells Calico how to set itself up. And so now if we take a look at our pods and kube system, we'll see that we've got a couple of new pods creating, but we'll also see that our core DNS in a moment is actually going to switch from pending to running. So once Calico is up and running, we can see that it's getting up and running. We've got a container for each node. It's a daemon set, so it's going to run on each node, which makes sense. You're going to want networking on every node. So in a couple of minutes, this will be done, and then we can go ahead and set up our ingress. And it's been a few minutes. We're back, and we can see that all our nodes are running, our controller is running, and now core DNS is running. So if we go ahead and take a look at our nodes, they should all now say ready. So we can actually do something somewhat interesting. Okay, so we've deployed Calico. All of our nodes have networking. The next thing we need to do is provide a way for network traffic to get into our nodes, aka ingress. Ingress controllers are really straightforward. They're web servers, so Nginx, HAProxy, Envoy, and they are basically just they're kind of the precursors in some ways to operators. They're controllers. They're listening for ingress configurations to come online, and then they update their own configuration accordingly. So instead of you putting together, say, a Nginx configuration that says, go look at these services, and we'll talk about services and load balancers in the next chapter, the ingress basically short circuits that. So you fire up Nginx, and Nginx is looking for these ingress configurations, as opposed to you as the sysadmin crafting a new ingress or Nginx configuration for every single service you're going to deploy. So we are skipping now to page 50, and we have another YAML in here. We didn't want you to have to go out to the Nginx website, because websites change. They apparently don't ask our permission first. I don't really know why. So let's go ahead and create chapter 2. And then we have our Nginx deploy. So that's going to go ahead and deploy the Nginx ingress. So we're going to have a new namespace here called ingress Nginx. And we can see that we have an ingress controller launching. What that means is that we will now be having an ingress Nginx controller running. We're going to want to probably make that HA. Let's take a look and see what we have here. So we have our client cluster. All right, so what I'm actually going to do is I want Nginx to be running on all of our nodes. So I'm going to convert Nginx from a deployment to a daemon set. Or actually, no, I'm just going to scale it to 3. That should probably get us there too. Kube control, or kube control, get deployments. And ingress Nginx. All right, so kube control deployment, or kube control scale deployment. Ingress Nginx controller. And 3 and ingress Nginx ingress. Yep. All right, so let's take a look at kube control get pods and ingress Nginx. All right, so that's running, and let's see. Guessing they're all going to be running on different ones, but let's take a look. O wide. All right, and we can see that we do in fact have our ingresses running. Well, those are going to be our internal IPs. Let's see here. Kube control describe ingress Nginx. All right, so that is going to be running on, let's see here. It's running on worker 03. Actually, kube control, clear. Kube control, get deployments, and ingress Nginx, describe, deployment, ingress Nginx controller. All right, let's see, is this going to say no? Yeah. Control describe node cluster 01 worker. All right, let's see what it's got running on here. So we've got a ingress controller on there. Oops. And we have an ingress controller there. And we have an ingress controller there. Okay, cool. So we have an ingress controller running on all of our nodes. Had I been a little less lazy, I just would have made the ingress controller a daemon set instead of a deployment, and that would have gotten it running on all the nodes. But like I said, I had gotten lazy. So the next thing we're going to do is we're going to go ahead and deploy our HAProxy container to load balance all of our ingress controllers. So there is already a script inside of here. So if I go to Kubernetes chapter 2, and we've got the HAProxy directory. Let's take a look at the script. Oops. Chapter 2, HAProxy. All right, so this script does a bunch of fun stuff. So the first thing it does is it uses Docker to get the IPs for each of our nodes. Then it goes ahead and creates a configuration for HAProxy for all three of our nodes, again, with the IP addresses. And then it starts the HAProxy container. So what you're going to notice here is that we're not running HAProxy inside of Kubernetes. We're running it outside of Kubernetes, even though it's in Docker. And that's typically going to be true of most of your load balancer deployments, where your load balancer is going to be external to your cluster. So for instance, if you're running a EKS cluster and you fire up a load balancer, that creates a load balancer inside of AWS, not a load balancer inside of your cluster. Same is going to be true of AKS and GKE and most of the others. There are, when you're actually firing up load balancer, and we'll get into this next chapter when we talk about load balancers and services and ingress more, what's happening is that your cluster is actually interacting with your cloud to set that up for you. Now, there are security implications to that, and the cloud vendors spend a long time making sure that those work, but we'll talk about that later. So anyway, we have this great script that should go ahead and let's set up our HAProxy. All right, so our HAProxy is running, and if everything was set up correctly, we should be able to get a 404. Let's see here. Yep. So that 404 is coming from Nginx, not from HAProxy. So next, Scott goes into the proxy flow. I'm not going to get really too deep into this because I want you to buy the book. But he really gets into the weeds into how HAProxy works and how the networking layers work. And just to show that things actually are working, let's go ahead and simulate a failure. So the first thing we're going to do is let's go ahead and kill our kubelet. So that stopped our kubelet. We're going to do a kube control get nodes. Now the first thing you'll notice is this will actually load. But the cluster is up and running. Cluster 01 worker 2. Stop kubelet. Apparently that did not kill the kubelet. So let's go ahead and let's see here. System control status kubelet. System. Oh. So this means that it is disabled. All right, so maybe we just need to give it a minute. Okay, so it took a minute. Clear. Yeah, probably end up launching on another one. So we're going to delete one of our pods here. So this will cause a new one to be created, but it still works because even though a pod's being destroyed, HAProxy is load balancing all of our pods. So even though it's going to create a new pod, all right, and we're going to actually just let this sit. You know what? Because I bet if we look at this, it's going to say pending. Why is it pending? Because it is trying to load on a node that doesn't exist, or doesn't have a working kubelet. Scribe pod ingress nginx. Okay, so we can actually see here that it can't deploy the node, which means we are now running with only 2 nodes for our HAProxy. So let's take a look at our HAProxy. And it doesn't look like the logs are actually going to tell us anything, but we can see that we're still actually able to get to nginx. That's because HAProxy behind the scenes is saying, oh, I can't talk to one of these, so I'll just talk to the other 2. So we're still highly available. So that wraps up this chapter. There was a lot going on here. We started off with just getting kube control and kind set up, simple cluster. We then moved on to standing up a multi-node cluster. And then once we had a multi-node cluster, we then said, okay, well, how do we actually make this useful by standing up the multi-node cluster, deploying Calico for the CNI, and then getting our nginx ingress deployed. And then finally, we set up an HAProxy to replicate what a load balancer might do in front of our ingress deployment. So at this point, you now have a running cluster. Like you could start deploying things into that cluster and start accessing them through your HAProxy, all without having to stand up an external load balancer or whatnot. What I also will say is that throughout the rest of the book, usually every chapter we say start with a fresh cluster because we don't want you to have to worry about, well, maybe you messed something up or you're tweaking something in another cluster. We say start with a fresh cluster. You don't have to go through these steps every time. I'm going to go ahead and destroy this cluster. So as this cluster is shutting down, we actually have a great script in here that does this all for you. And kind of like I said, this has become my go-to for I need a quick cluster to do some testing. So in here, let's go ahead and remove our HAProxy. Nope, gotta kill it first. And now let's remove it. So we've got clear Docker. So now if we go into chapter 2, the script here called create cluster is going to do everything we just did manually automatically. And that's great because that will just get you, these steps are great because, what we didn't want to do with the book was, if you're going to draw an owl, draw 2 circles, and the next screen there's an owl. We wanted to show you the details of how this stuff came together. But you don't want to have to repeat that for every single chapter. And that's the great thing about Kubernetes is this is all automated. So once this script is done running, you're going to have a fully functioning cluster that is the basis of what we'll use for each and every chapter moving forward. Layer this on top of, or layer on top of this when we get to chapter 5 and start talking about Open Unison. We'll make it so that you can access this cluster remotely. So like I said, I use these clusters for everything, just about everything. The one word of warning is they don't tend to survive a reboot. If you want to use something that will reboot, look at something else that will deploy a standalone kind as opposed to, or a standalone kubeadm rather than kind. But as long as you're okay with losing stuff on a reboot, this is a great way to stand up clusters quickly. So this is going to take a couple minutes, but you don't have to sit here and watch it run. That said, thanks for joining. As they say in YouTube land, smash that subscribe and like button. It really does make a difference. And hopefully you're enjoying the book, and we will see you next week when we talk about Docker Bootcamp. Thanks, everyone.